All right, I'm going to go through a few trig identity problems for you to review. So I would pause this video and grab your trig identity sheet because notice I don't have them on the actual video, but I will certainly be referencing those since you don't have to memorize them. So the first one says secant squared x over tangent squared x minus 1, and you're asked to simplify it, so you just want to take it as far as you possibly can. So on my, I notice, I have some squared functions. So two things I told you. First, if you can get everything in terms of sine and cosine, that's often helpful. However, we don't have any sines and cosines here, so that maybe wouldn't be my first step. Second option, of course, when you have things squared, those Pythagorean identities usually come in handy. Third thing is if you have fractions that might need a common denominator, you can go that route. But precedence is probably if I have something squared, I'm going to go Pythagorean identities. If that doesn't help me out, then maybe I would find a common denominator. So I will start with my Pythagorean identities, and I note that one of them says 1 plus tangent squared x equals secant squared x. So I can replace my numerator, which is secant squared, with 1 plus tangent squared x, and that's minus 1. Then I might rewrite this denominator over both of those because I can see that here my tangents are going to cancel out. So I'm going to write 1 over tan squared plus tan squared over tan squared, and then again you can see that cancels out to 1. So I have, I'm going to come over here, 1 over tan squared x plus 1 minus 1, right, because this is just 1. So then those cancel each other out. And 1 over tangent, of course, is cotangent, so 1 over tangent squared would be cotangent squared. And that is as simplified as I'm going to get. All right, the second one says 1 plus cosine theta plus 1 over 1 minus cosine theta. And notice everything's already in terms of cosines. There's nothing squared, so I'm not going to use my Pythagorean identities. So, however, I do have two fractions, so my recommendation, of course, when you're adding is to combine them. Please understand, way back from when you're finding least common denominators, that your quantities, 1 plus cosine, is, well, they're quantities. So when you're finding that LCD, they have nothing in common because this one's plus, the first one is plus and the second one is minus. So your LCD is going to be 1 plus cosine theta times 1 minus cosine theta. So, and I'm adding these, of course. So my first fraction has to be multiplied by 1 minus cosine theta. So I have to multiply the numerator by that also to balance out. And the second fraction has the minus and needs the 1 plus cosine theta. And the numerator needs 1 plus cosine theta also to balance out. And again, don't cross these out because then you would just undo what you did, which would be absolutely ridiculous. But now that I have a common denominator, I can add these two together, and I should distribute the 1 through, but I'm sure you can see that that does not change a thing. So I have 1 minus cosine plus 1 plus cosine. So my cosines are going to cancel out. I'm going to have 1 plus 1, which is 2. And then I'm going to FOIL out my denominator because I don't really have any identities that I can do anything with that involve a 1 plus or minus cosine. So I'm going to FOIL this denominator out. So that's going to leave me with 1 plus cosine theta minus cosine theta minus cosine squared theta, and my cosines are gone, so that's 2 over 1 minus cosine squared. Well, now I do have a Pythagorean identity that involves cosine squared, And you know that sine squared theta plus cosine squared theta equals 1. So if I take this and subtract it over, I know that this is really just sine theta. Okay, so I can continue on and change that denominator to 2 over sine squared theta. You do know that the reciprocal of sine is cosecant, so you could also make this 2 times cosecant squared theta. I would take either answer, just so that you know. It's probably best to leave things in terms of sine and cosine, but either of these would be appropriate. All right, this next one is a verify, and remind yourself that verify means you want to get one side equal to the other, so that's supposed to be an equal sign in the middle. So cotangent minus cotangent squared theta minus cosine squared theta equals cotangent squared theta times cosine squared theta. What a cool thing. So I'm going to work with the left-hand side. Again, it really doesn't matter which side you choose. So I'm going to change my cotangent, I know, is cosine over sine. So cotangent squared would be cosine squared over sine squared. And I'm going to leave. So I'm getting everything in terms of sines and cosines. I should probably clarify that. And I'm going to stick this over 1 and then tell myself I probably could do the common denominator route. So obviously the common denominator would be sine squared. So cosine squared over sine squared is good to go, minus cosine squared needs a sine squared, so I'm going to multiply the numerator times sine squared also. Then I can combine my numerators, so I really have cosine squared minus cosine squared times sine squared all over sine squared. And I'm going to, I don't know if you see up here, but I can factor out a cosine squared from both. So I'm going to do that and see what happens. Cosine squared theta will leave me with 1 minus sine squared theta. And hopefully you're starting to identify, again, the Pythagorean identity says, one of them says sine squared theta plus cosine squared theta equals 1. So that means cosine squared is 1 minus sine squared if I just subtract sine squared. So I'm going to note that this and this are the same, so I'm going to replace this with cosine squared. Okay, well then I can, let's see, what can I do? Well, I have cosine squared theta over sine squared theta times cosine squared theta. And I know that this cosine over sine is cotangent, so squared over squared would be cotangent squared, so I can make that a little bit better. And I just want to make note, since you can't see it anymore, but if I go back up to the top, I was trying to get to cotangent squared times cosine squared, and that is what I just got to. So this equals cotangent squared times cosine squared.